So what exactly is a graph? Well, what it does is that it shows you the relationship between the independent variable, right, which is normally placed on the x-axis, right, with the dependent variable, which is placed on the y-axis, right? So science is all about variables, right? Things changing, right? We do something to something, and we see how it changes, right? And so in this case, we have a balloon, and we're raising the temperature of the balloon, so that's the x-axis, right? And as the temperature of the balloon increases, right, so does the volume of the balloon. So we're heating up this balloon, right, from 0 degrees all the way up to 100 degrees. And as we're doing that, the volume of the balloon also increases, right? Also increases, right? We start out here at 0, and we're going up to 100, and you can see in the picture and in this line that it's going up and to the right, which means that it has a direct relationship. Turns out that volume has a direct relationship, direct relationship, there it is, with temperature when we're talking about balloons. If I can write out the word balloons. There we go. When we talk about balloons, right? So that's really interesting because there's a lot of things you can determine just by looking at this graph, right? So one of the most important things is the fact that I'm actually going to clear this out so I have some room here. So we've already established that it's got a direct relationship, temperature and volume. When you talk about heating up a balloon, remember that the x-axis or the dependent variable always depends on the. Did I say x-axis? I'm sorry, that's the y. The y-axis or the dependent variable always depends on the x-axis or the independent variable. That's very important. Okay. But this line here that shows us that we have a direct relationship here with temperature and volume in regards to this balloon. This line here actually has a very special equation, and this equation is called. Whoops, I messed up there. That's not the equation. It's y equals mx plus b. It turns out that any line on a graph has an equation, but when it's a straight line like that, it's y equals mx plus b. Right. So what are the parts of this particular equation? Uh, we'll start out with this, the y. The y is the y variable, so whatever number on the y-axis or value on the y-axis that you're interested in. And then x is whatever value or number is on the x-axis, right? So that's an x value, and this is a y value. That doesn't even look like the word value. Value, there it goes, right? And remember, y depends on x. Over here, b is actually known as the y-intercept, right? On this particular graph, the y-intercept is right here. It's just above 22. We don't know the exact number, but it's just above 22. It's not right there at the point of the graph, right? So it's just above, so we're not really sure what the y-intercept is. But let me tell you, we can figure out what the y-intercept is just from the data on this graph, right? And probably the most important part of the y equals mx plus b equation is this. This is the slope of the line. The slope tells you the relationship, and you get most of your information from this equation and the slope, right? So let's do some math and figure out, some things about this graph here, okay? What is the slope? Well, the slope is known as rise over run, or the amount the value increases in the y over the amount of the value increasing over x, right? So these coordinates, by the way, right, all these different points, they have a very specific annotation, not annotation, but syntax or way you write them. It's always x comma y, right? And if you want to figure out what the slope of this line is, right, all you have to really do is go to points on the line that you do know what the x and y are and put them into the equation to figure out what the slope is. So slope, or m, equals the change in y over the change in x. So a second ago I said rise over run, right? Rise because this is the change in y and it's going up, rise. And then run because this is the change in x and it's going that way and it's running to the right. It's not rising, right? And the equation to figure out what the slope is m equals x, oops, I messed up, y2 minus y1 divided by x2 minus x1, right? So that's what that means when I say the change in y, which is the second y value minus the first y value, divided by the change in x, which is the second x value minus the first x value. So let's clear this off and see if we can see any numbers we can use on the graph, right? Any points that are easy. Well, here we go. We have this one right here. We can see that the x value for that point is 20, and then the y value for that point is 24, right? So this would be x1. Oops, I drew a y for some reason. This would be x1, and then let me make it a little bit clearer. That's just such a bad handwriting. There we go. That point right there, and this 20 here would be x1, right? And then this 24 over here, right, would be y1. So how do we choose y2? Well, let's see if we can find a point that we can use. Oh, this was good right here. I think this is really good. That point's good, right? Because it's exactly in the middle right here between 80 and 60. So that's got to be 70, right? So 70 here will be x2, right? And then that one's on that line right there, and so we go to the line, it's 28. That will be y2. I don't know why I did that. Why did I underline the x values and circle the y values? Who knows? So let's plug that into our equation, right? So if you recall, m, or the slope, equals y2 minus y1 divided by x2 minus x1, right? So what does that equal then? Let's plug in our numbers. y2 is 28, and then y1 is 24, divided by x2, which is 70, and then minus 20, which is x1, right? And then that will give us our slope. So this is just easy arithmetic here, right? 28 minus 24 gives us 4, and then 70 minus 20 gives us 50. So that is 4/50. Let's reduce that a little bit. If we reduce that down, that actually becomes 2/25. So that's the rise over run, or the slope, right? So as we look at our y equals mx plus b equation, right, we've figured out what the m is now. The m is, for every 25 spots on the x-axis we move to the right, we move up 2 spots on the y-axis. That's our slope, right? Cool. Well, now that we have our slope, we can figure out all kinds of stuff, right? For example, what actually is the y-intercept, b? What is that? Well, this is actually really simple to do now that we have the slope. We have our equation, right? Y. You can plug in a y value, right? Say we'll use 24 because we used that a second ago. So 24 then equals the slope, 2 over 25, 25 fifths there we go, times x. What is the x that corresponds to that y? That's 24, and it corresponds to 20, right? Plus b. And now we have a variable to solve for, okay? How do we solve for that variable? Super easy, right? Because the b is by itself. We want to get b by itself, so all we have to do is say 24. Oops. Let's try that again. We subtract this entire part right here from both sides. So then what happens is we have 24 minus 20 into fifths. No, 20 fifths. No, wait. 2 25ths. There we go. 2 25ths. Wow, that was difficult for me. Times 20 equals b. And then we can solve for b now, right? That's great. We can solve for b now. So if we do this arithmetic here, right? So I don't really know if you guys remember, but a little quick review here. We have this thing called the order of operations, right? And most people like to remember it by using this little saying, right? Which is, please excuse my dear Aunt Sally, which is parentheses, exponents, right? Multiplication, division, right? Addition, subtraction. That's the order of operations. And when you're solving for equations, you definitely need to do that. You need to use the order of operations. In this case, for example, the first thing you would need to do here is to, since parentheses and multiplication is first, right? You need to multiply right there 2 25ths times 21st, and then subtract it from 24. And the order doesn't always, you can do it out of order sometimes and get it right, but you can do it out of order sometimes and get it wrong. Whereas if you always follow the order of operations, you will always get it right, right? So doing that, let me switch over to the, I was trying to decide whether or not I should show you on the calculator. I might as well do it. Okay, so let's see here. Calculator. We'll clear that out, right? Another reason why I really like this calculator, okay, is because you can use it with fractions, and you can see fractions very clearly on the calculator. So to put in the fraction 2 25ths, right, into this calculator, what you do is you use the parentheses right there. You type in the 2 25ths as you see it, right, on the page. And that's a fraction, 2 25ths. And you want to multiply that by 20. Right? You can actually also just put parentheses around it too, and it'll work as well. And then hit enter. And we get 1.6. You get 1.6, right? So now that we have 1.6, here's another really cool thing that this calculator can do, right? The next step actually is to subtract 1.6 from 24. So what you can do is type in 24, right? And it actually stores your last answer that you had in memory. So minus, and instead of adding in 1.6, typing it in, I'll just hit the second button and then hit the minus sign down here. It also has an A and S on it, so it stands for answer, and it says answer there, and that was my last answer. And I can hit OK, right, or enter, and it'll give me the answer. So that's super handy, that answer button, because let me just tell you, sometimes when you do calculations, the number is going to be really long, and you're not going to remember what it is, or you'll write it down wrong. But if it's saved in the calculator as the last answer you used, it's a lot easier to do the math, right? So there we go. What does that mean then? I'll go ahead and minimize this down so you can actually see the rest of the problem. There we go. B, or the y-intercept, equals 22.4 So that number right there, this value, this dot that we were just talking about right there, where the y-intercept is, the value there is 22.4. Well, that's really cool. That makes it very, very helpful for a lot of things, right? Let me show you why, especially when you have a graph. So let me clear this off. All right. If you recall now, our line of the equation, the line of this equation is now y equals the slope, which is 2/25, right? X plus the y-intercept, which is 22.4. But you're asking yourself, how is that helpful? There's two variables now. Actually, there's not two variables. It's there in the equation as two variables, but now you can figure out what any of the points on this line is, right? Any of them are, because you have the equation of the line. And you can figure out then what the corresponding y value is to the x value, because y depends on x, right? So for example, you have here, for example, let's say we want to do what was the number at 80, right? What is the volume of the balloon with the temperature right here is at 80 degrees Celsius. At 80 degrees Celsius, what is the temperature, right? Sorry, not the temperature. What is the volume of the balloon? Right? At 80 degrees Celsius temperature, what is the volume of the balloon, right? We don't know. Let's plug in and see. We want to know what the y is, because that's the volume. 2 equals 2/25, right? Times x, which, what is x here? It's 80, because that's what we want to figure out the corresponding temperature to is. Sorry, the corresponding volume is to that temperature, right? Plus 22.4, which is the y-intercept, right? Sorry, my 4s look like 6s, but that's okay. And now you just do this very simple math right here, and you can figure out what the corresponding volume is to the temperature of 80 degrees. All right, so let me go ahead and put the screen on the calculator on the screen again, and we'll clear it out here, and we'll type in the numbers, right? So y equals, which we don't have to put in the y equals part, but it's, remember the fraction, it's 2, uh-oh, I lost connection to my calculator, there it goes. 2 divided by 25, right? 2 divided by 25, and then times 80. Remember earlier I said you don't have to put the times symbol in there, you can just put the parentheses and it'll make it times 80, right? Plus 22.4. So here's another pro tip, right? To make sure that the order of operations is working on your calculator, which it always does, but just to make sure, I always like to put the parentheses in more parentheses to make sure the calculator knows that, hey, you're supposed to do the multiplication first. Oops, that's a percent sign. There we go. Right? Make sure it does the multiplication first, right? So there I have parentheses open, 2/25, close parentheses to multiply, and then 80, close parentheses again, and then it does that part first, and then it adds the 22.4. And then we'll hit enter. So at 80 degrees Celsius, the volume of the balloon is 28.8 liters. Wow, that's kind of a big balloon, I think. Kind of a big balloon. So, yeah. Pretty cool. Pretty cool.